So today we're going to continue what we did yesterday. However, we are going to see some notation changes. So instead of saying the inverse in words, you're going to actually see this notation which represents the inverse function. So it looks like a -1 exponent, basically. Remember, we found out yesterday that sometimes the inverse is a function, sometimes it's not. And you can test that using either your horizontal line test or your vertical line test. Or you can also think algebraically, would each input value have one output value? So today we're going to be given one function and asked a series of questions about it. Your homework will look kind of similar. Consider the function f of x equals the square root of 2x plus 2. Notice that this does not have a positive or negative in front, so technically this is just a positive square root. They ask us to find the domain and range of this function. Okay, well, we know the domain is always all real numbers except for two instances. What are those two instances that it's not all real numbers? Emily?
Square root.
Square root, which we do have one here. So that would be our radicand is greater than or equal to 0. What's the other one? Brett?
Denominator.
Good. Denominator can't be equal to 0. So we have one of those cases here. We have a square root. So we're going to say the radicand must be greater than or equal to 0 for our domain. So you're going to take whatever is under the square root, which happens to be an algebraic expression, 2x plus 2, set it greater than or equal to 0, and solve for x. So we'd subtract 2 and divide by 2. So x is greater than or equal to -1. Just as a warning, on the book answer key, they use set builder notation, so it'll look like this. We'll say x such that x is greater than or equal to -1. You're not required to do that. I will teach you set builder notation later on in the year, but I talked with the pre-calc and calc teachers and they said this is fine for describing your domain and range. Now, the range, this is something new. We haven't really talked about the range in a while since we did like quadratics. So there's two ways that you can calculate the range. One is obviously by graphing this in our calculator and looking at it, which is the easiest. But if this were a no calculator problem, what you would want to do is create a little table of values using the domain you found. So the domain has to be numbers that are greater than or equal to -1. So say -1, 0, 1, and 2. Plug those in and see what kind of values you get, and that will tell you what it looks like. Well, first of all, do you guys remember what the square root function looks like just in general? An idea of it? We looked at these the past couple days. The square root function. I compared it to a shooting star. Yeah, just starts somewhere and just kind of shoots off in one direction. Now, since this is just a positive, it would only be part of it. If it had the negative, it would also make like a sideways parabola. So just to give you an idea of what we're looking at. So when I plug this number in, I'll have 2 times -1 is -2, plus 2 is 0, square root of 0 is 0. Plug in 0, we'll get the square root of 2. Plug in 1, 2 times 1 is 2, plus 2 is 4, the square root of 4 is 2. And 2 times 2 is 4, plus 2 is the square root of 6. So you can see that the numbers are getting larger in the y column. So really we're going to say that the y values have to be greater than or equal to 0. Now, I did say we could do this graphically, so let's take a look at the graphing calculator. If we were doing this in our calculator, we would type in the square root of 2x plus 2, and then close our parenthesis, and zoom 6 to give us a standard window. And you can see more precisely that, yes, the x value starts at -1 and goes into infinity, and my y values, the smallest the y ever gets, is 0 to infinity. So remember, you can also write it using our brackets and parentheses. So if you wanted, you could do -1 comma infinity and 0 comma infinity. If you prefer, if Bree were here, she would probably want to write it that way. She likes it. So I would obviously accept either of those answers. Now, they want us to find the inverse. Remember, that's what this symbol stands for. How do we find the inverse of the functions on our homework in yesterday? It's the first thing we do. Evan?
Switch the X and Y value.
Good. Switch the x and the y variables, or swap them out. So right now you don't have a y variable, you have an f of x. You may want to make that a y so that it makes more sense. Okay, so we'll swap the y and the x to make this x equals the square root of 2y plus 2. And then we solve for y. So we will square both sides. So we get x squared equals, the square and the square root are inverse, bless you, operations, so those undo one another. And then we would subtract 2. And then we would divide by 2. Now, since they did ask us to find the inverse, f negative 1, your final answer, I would like you to put that back in there. So we have x squared minus 2 all over 2, which this is a perfectly acceptable answer. However, another possibility would be to split this into 2 fractions, which would be 1/2 x squared minus 2 divided by 2 is 1. So if you prefer to simplify that way, you can. Then it asks us to find the domain in the range of the inverse. Now, who remembers yesterday, whenever we had the inverse and the original, what happened with the domain and range? They reversed, okay? So to find the domain and range of the inverse, all you have to do is look up at the original and reverse them. So the domain will become the range and the range will become the domain. But be careful. You do have to change the variables because x stays with domain and y stays with the range. So the domain would now become the range. So I'll change that to y is greater than or equal to negative 1. And the range will become the domain, which I'll change to be x is greater than or equal to 0. All right, now we actually are, by doing this, we're stating a restriction on the domain. Because if you think about the function we found, this is quadratic, which means it should look like this, right? But I'm telling you now that the domain is only x is greater than or equal to 0, which is saying it's only going to be this part of it. Now why? Go back up to the graph we had up here. Remember, we only had half of that sideways parabola. So whenever we take the inverse, we still are only going to have half of it instead of having the whole thing. So that's why we need a restriction on the domain. The last 2 things they ask us to do here are to find composite or composition functions. So we're going to do f of f negative 1 of 2. So kind of like we used to do f of g of x. So start on the inside. We're going to find the inverse using 2 as our x value. The inverse is this function we found up here, our x squared minus 2 all over 2. 2 squared is 4. 4 minus 2 is 2, and 2 divided by 2 is 1. So I'll take that and replace it back over here. So now I have f of 1. This is like what we did a couple days ago with our composition of functions. Now I'm going to find f of 1 using the equation all the way up at the top, which was the square root of 2x plus 2, right? I can't see it. Yes. So we'll plug in 1 there. Now look what happened. We were inserting 2 and we got 2 out. So it might just be a coincidence that that happened. But let's do the next one, which they have the inverse on the outside, the regular function on the inside, and we have 3. So let's see if we get 3 also. Maybe this is a pattern we can kind of find when we're doing an inverse composition. So first we'll find f of 3, which is the square root of 2 times x plus 2. So that'll get me 6 plus 2 is the square root of 8. Don't bother breaking that down into 2 square roots of 2, okay? Because we're going to plug that in somewhere else. If you do, it's okay, but it's not necessary to simplify this. Now we'll plug that in for our inverse, which that function was our x squared oops, it's minus 2. X squared minus 2 over 2. So we plug in the square root of 8 for x. Well, the square root and the square, again, are inverse operations. They undo one another. So I'm just left with 8 minus 2 over 2, which will get me 6 over 2, which is 3. Okay, which we notice matches. Okay, that's something that is going to happen every time you take a composite function that has the regular function, its inverse, and a number. You'll get back to that number. Because remember, the inverse function basically undoes the regular function and gets you back to where you started. Okay, so for the sake of time, we're not going to end up doing these over here, but we can see that they would just end up being 2 and 3. And if you wanted to prove it, you could. We are going to do the top part of this one because it's pretty simple, but we want to look at this function. What type of function is this one? 10 minus 3x. Linear. So if you were to think of it, it's just a line. You also might want to rewrite it in slope-intercept form, which would be negative 3x plus 10. So that would be starting at 10 with a slope of negative 3, so it looks something like this. What are the domain and range going to be for that? Do we have a denominator? Big square root? All real numbers? Also, look at the graph. It's going on forever and ever and ever in the x, and also in the y direction, right? Because it's going up and down forever. So the range would also be all real numbers. To find our inverse, we will flip-flop our y and our x. So this would become x equals 10 minus 3y. And we saw a bunch of these in the homework. We would just subtract 10 and divide by negative 3. Now, you don't want to leave the negative in the denominator, so you have two options. You can divide each term by a negative. So this would be like a positive divided by a negative is a negative x. And negative 10 and then negative 3 would cancel to become a positive 10 all over a positive 3. Or your other option is to actually split them up into two separate fractions, which would be like negative 1/3 x. And then negative 10 over negative 3 would become positive 10/3. Doesn't matter to me how you leave it, just so you don't have a negative. Instead of having y there, I should have f inverse. Now it asks us then to find the domain and range, which remember, to find the domain and range, you just have to flip-flop the domain and range of the original, which both happen to be real numbers, therefore this also would stay all real numbers. Also think about the inverse. The inverse is also a linear function, so that makes sense. Okay, let's get to one of the word problems on the back. They're very simple, so it shouldn't be really difficult. When you're doing the word problems, instead of actually switching the letters though, like the y and x, you're going to keep the letters the same, but you're just going to solve the formula for the other variable using inverse operations, which we've done a ton of times. So the first one says we have a function d equals 16 t squared. D is distance, t is time. Find the inverse function. So that means we're going to solve this for t. So you don't switch the variables, you just leave it the way it is, but solve for the other variable. So I would undo multiplication first with division. Then I would undo my squaring with a square root. Now you can put a big square root here, or you might want to put two separate ones to remind yourself if you can take the square root of a number, you will. Now technically this does get you positive or negative square root of d over 4, but we know time can't be negative in the real world, so you don't need the minus. It would just be the square root of d over 4. And then it also says to use this inverse to estimate the time it takes for an object to fall 50 feet. So that's our d quantity. So we just plug in 50 for D, and then this goes in our calculator, because we don't want to leave it in simplest radical form. We actually want to know like how many seconds. So when you type it in, just be careful that you would close your parentheses after the 50 before dividing, and we should get approximately 1.17, or excuse me, 1.77. And that is in seconds. All right, I'm gonna skip over that next one. We can come back to it if we have time. But we would just solve that one for V. The bottom questions we talked about on the front. Whenever we took f of the inverse of f of 2, we got 2, or 3, we got 3. So whenever you see a function and the composition of functions are being done with the original and its inverse, okay, so we have like f of -1 of f of x, you're just going to get x back, okay? Because again, these are kind of thinking of them as like inverse, undoing one another. So for any of these problems, you don't even have to read what f of x is, because they want you to do the inverse of the function of 652. The answer is 652. If you do the regular function of the inverse of negative square root of 86, you're still going to get negative square roots of 86. So literally no work required, but just for you to understand that those things undo one another to get us that. So for 17, again, this part is irrelevant. If you really wanted to, you could find the inverse and you could do the composition to prove it. But we did that on the front, and now we can just kind of shortcut it. So this would be 777 and negative 5,802. Okay. Since we didn't have time to go over 15, I'll give you what the answer would be. You would end up getting V equals 8 square roots of D, and then you would plug in 30 for D, and you would get 43.8 feet per second. And that's again if you were to solve for V using your inverse operations. Okay, homework is on my